Cool. So, turns out, um, okay, somehow I show it at once. But anyway, this is the statistic. We have like genre canon as the first, and South America is actually the one in the end won the prize. And so I guess the point is there are some degree of consensus. It's not like, well, people like drastically different stuff. It's like, well, we do have some degree of alignment. We can look into some of the things people talk about why they like these songs. Genre canon particularly, it's like made use of the advantage we got with AI. So, this is interesting because it's like instead of relying on it to generate everything and replace creativity, so think about AI in the way that augment human creativity rather than, using AI to do the same thing that human know how to do it. I mean, not saying that human couldn't do it, but it's just less obvious to do that, that number of genre transition in just one single song. And they have varying musical styles that transition into one another very seamlessly. And this is also one of my key section that I like is that transition from the Star Wars, cantina style piece into rap rock, and then somehow just move away into some abstract percussive section. I think I agree, that's the highlight section of this song. And South America, it's also nice. It's like it makes an actual cohesive songs to my ears. So sort of like, production ready-ish, um, craft intricate soundscapes while retaining a warm, organic quality. It surprisingly captured the essence of Latin American pride and culture in a way that feel genuine. And hard not found. How you can make a real song using AI without it sounding like it was AI, and more to serve an artistic message within their song. So this is also interesting is like people find different values in how you should use these tools. It's like one way is like the genre canon is like exploring the limits of AI, what AI can do. But in the end of the day, it's like depends on what you want. If you want something that people like or, sort of like fitting into your playlist, then this is sort of another way to think about it. We don't want it to sound, drastically different or, so AI-like, but rather, can we sort of like fit in our original goal and the way how we used to, create music, and just AI become part of it within that process. And this is the ambient song you were talking about. So by using their own composition. So this is the interesting about their process. They use their own composition as the training data. So that, AI's output sort of like customize and personalize into their own, vision or their taste. So that's different from the other, entries. Those are, mostly taking pre-trained models without, adding their own values into it. Explore ambient music, rich with sonic textures that challenge my expectation of AI compositions, of course. And there's also one vote for one mantra, distinct, but so amorphous that it isn't initially obvious AI constructed. And the binary one, that's the meta one, it says, this is one of the only submissions that actually accurately recreated its source material. So this is interesting because when you sort of like confine your genre into one, then you can sort of like guess what your model is doing. But if you train the models, think about like, I don't know, if you train on all the genre, just think about classical. If you train on all the classical music, what are you expecting? You never know. There are so many different subgenres with that. So what are easy? I think this is much easier than the other task. So, people talk about getting ideas, creating lyrics, even though someone don't agree, but at least relevant to the subject of the song, rather than actually having that emotion depth, but, at least it stays relevant to the subject of the song. Generating loops, that's, small chunks of reusable sort of like materials. That's also something AI can do reasonably good enough for now. Synthesizing instrument sounds. And this is not something too tricky because synthesizing sounds is something people have been doing without AI. So it's sort of like learning that pattern of how timbre works. And generate innovative sound effects and synthetic timbres, and finally making a solid beat or a group. But I guess more interesting is what are difficult. So some of you likely know what those are, but some of the most common thing is, first vocal. So, voice AI can be improved a lot, struggling to produce anything expressive or natural vocals. So some of these model depends on what the model they are using. So some of them are like text to singing voice generation, then text to voice synthesis. Then in that sense, it's like you just input the text and then you get everything out. But there are also like voice cloning model. That's when you see a better, some more nuances in the generated sounds. That's when you sing and then you transfer it into another person's voice. That's something, this Moises, like the vocal lab, I forgot what's Focus Studio or something. But that's what they are doing. So that's two different tasks. One is like, just basically from, typing, and then you just get the sound. So in that sense, you don't have much control on what you get. But the other one is that, you sing, and, if you know how to do vibrato, you will get vibrato. If you don't know how to get vibrato, you don't get vibrato. So in that sense, when you're doing voice cloning, you get some sort of, controls, nuance control in the sound, in the vocal that you generate. And AI voice are always wacky and lyrics intelligible and lack of emotion depth. So that's the second point. Emotion depth is like mostly these music stay at the surface level. So lacking emotion depth and nuance, feel technically proficient but lack soul. This actually echo in the second or third lecture, we talk about, that AI generated thing, and the composer basically claimed that, there's no soul in the music that's being generated. Is that because when we are actively listening to it, we are sort of like thinking about what's going on behind the thing, how people create this music. And because you sort of like reflect, have that expectation that this is generated by AI, and so you sort of like feel that this connection. But so I guess that's also one of the interesting thing when you do, listening tests, but you sort of like intentionally let them believe that it's actually human generated, then, human composed, then what will be the result? And, again, more emotion thing. And there's also another thing that's commonly brought up is the coherent, storyline. Coherent and cohesive is one of the things that AI struggling with. So the reason I just talked about is that, most of these AI models, if you do really want to generate some structure, you sort of have to prompt it differently for different structure. And so at the end of the day is that, well, the composer have to think about, maybe your baseline, you just write it yourself so that it connected. So there's always that, very sort of a weak link across all these different materials, because these different materials are sort of like generated differently with the model. So that's also one thing that, AI struggling with for now. Cool. And these are some of the other things. One shot create AI music. I don't think that's useful at all, but that also shows that it's not possible for now. And so even like Suno claims something like that, but it's like, well, if you're generating cliche songs, then why should we get more cliche songs? We should be generating more interesting music if AI could do it. Or how can AI help us to sort of explore the boundary and push our creative boundaries? Phrasing is another big issue. So, the lyrics, the relation between lyrics and melody is still really bad for now. And details. This is likely on the quality of this song. So most of the model, at best, can do 48K hertz, but most of the model is running in 16K hertz. As for now, but I guess in the next few years, once people have more, high fidelity music, and we will see. Maybe AI just couldn't generate that kind of sound, but for now, lots of model is actually being at 16K hertz, so it's even lower sampling rate than CD quality. So you definitely, if you are using, good enough headphone, you can tell that just by listening to the quality of the recording or the music, the audio itself, you can tell that it's not production ready quality for today's standard. Cool. So that's some of your colleagues write about. So I guess here's something that I want you to sort of think about. So first, to what extent of human involvements can a song still be called AI music? That's something I just keep thinking about. It's like, why are we coding these things AI music? And if it's like 90%, human composed, but what's the point of coding it AI music? Is it just like because it sell, or it's you can write a news? But to what extent of human involvement can the song still be called AI music? I think that's people don't know yet. And when people code something AI music, sometimes it's just being prompt, or sometimes the audio is being generated, or sometimes it's 90% AI, sometimes just 10% AI. So for the AI song context, I think they are more on the more AI spectrum. So they sort of wanted to see how human and AI could create. And by that sense, I think it's on the more AI way than people assume. And, the ultimate way, the more AI spectrum is sort of like those like one-click one, but those are, generate really bad. And then on the other side is like, well, 90% human composer, but just 10% of AI stuff. But for AI song contest, I would say it's more in the middle where there are equal weight on AI and human inputs. But still, and the second one is like, shall we intervene if AI generated material doesn't sound polished? I don't know. I mean, it has its own characteristic, and that's sort of part of the interesting thing about it. It's like sort of think about electronic guitar. It's like originally it wants to recreate the sound of acoustic guitar, and people soon realize, well, it's sort of impossible. And people nowadays still trying to do it, and people now like trying to use AI to generate it. But what's the point? It's like you do have like acoustic guitar. Why do you want to recreate it perfectly using using a laptop? So the point become like people realize you can do distortion, you can do all kind of effects, and you can sort of like drive it into some interesting way to create your expression. So at that point, sort of like we just redefine how we use it. So it's sort of the same as these AI generated material. Is like, well, it doesn't sound like our the music that we have, or at least doesn't sound like the training data in 100% sense, but maybe it could become a characteristic of it. Any thoughts on these?
I feel like Well, one, I feel like it's hard to define, like, what is, if we're using like a percent for the AI, what is, I feel like when people talk about AI music now, it's generally just stuff that's generated. Like
Yeah.
any of the song the AI contest, because, I mean, anything using a DAW, you're gonna, like, most of the features are AI of some sort, so, like, where necessarily do you draw the line? I feel like AI is at its most strongest when it's, I feel like we all kind of agree on this when it's used to augment creativity rather than, just say generate a song and here it is. I think one thought that I have is like people who make beats in general. I mean, they're really good at taking samples and essentially making it something completely new. And I can foresee kind of some producers in the future maybe saying like, generate me like a really small loop or whatever, and then essentially making something new out of that and mixing and chopping that up. I feel like that's the direction, that's the ideal direction for it to go down rather than, just fully tell a model, I want a song that sounds like this, and then pushing that out to the market.
Cool. And if you look into these songs, and you realize that one thing that people like to use the most, not even these songs, it's like source separation. It's when you're doing sampling, you sort of like do source separation a lot of time. And that's something that's the least AI thing in all these AI music tools. But somehow that's something, we couldn't do it. It's like, if I give you the waveform, how do you even like, do source separation? It's feel like we can do it, but it's like that's our brand is doing some cool, operation that you can attend to a certain instrument, but rather than, actually, extract them or separate them into two waveforms. But that's something, sort of like AI just nail it in some sense. So that's also another dimension of it, is like there are just some tasks that's, feel tedious for humans, but somehow it just hard to imagine how we can do it without any help with computing. So that's also one thing. And the thing you mentioned is can it augment human capability, but also there are also tedious things that we just don't want to do it. And that's sort of lots of things being in adult, because a lot of automation, a lot of things you can call it AI or not AI, but that's sort of the thing. Is like these tools should help us to get rid of the tedious stuff so that we can focus on more creative things. Any other thoughts? Shall we intervene?
I'm a big fan of like AI tooling. Yeah,
Tooling?
everyone's used like stem separation from like AI ML. But like even like MIDI generation, it's like preset, it's like preset generation. I'm a big fan of that. I'm still a little uncomfortable. I guess it goes like a general question of like, what is art if it's just made by AI? Because there's a time and place for like fully generated artwork and audio. Like if you're, I guess, creating a promotional video, you're the only one, you don't know how to make music or how to draw something.
Yeah.
There's a place for that. Actual commercial listening. I would not be a big fan of using AI just for that. Like just a lot of people just spam like pseudo and then post it to Spotify and then you get royalties. I think it's like another question, should everything be watermarked? Like should people know, should it be like legally required to disclose that whatever media you're looking at was generated or partly generated? I think it goes into a whole like complete more general set of ethics questions.
Yeah.
And like, to what extent can you use AI tooling and still be called music? I think that using a stem and like to extract a song and make a remix, like bootleg remix or something, that's fine. But like if you're using a MIDI generator, are you really the one writing the music? If you use a MIDI generator and like a AI synth preset or something, are you really the one that's writing the music? But you could also be just using tools and stitching it together yourself. So yeah, I think it's pretty hard to define a line.
Yeah.
And like I know record labels are doing a lot of like UMG, like Universal Media.
Mhm. Yeah.
A lot of like
Sweet.
the partnering and yeah, and using for some record labels are like using their artists' voices to create models without the permission.
Yeah.
Stuff like that.
Yeah, that's one thing interesting. We were talking about the legal thing at the last class, I guess, when we talk all about these technology. But one thing interesting is that, think about the visual art community is like they're sort of like in trouble because, if roll back like 10 years ago, people are like, musicians are like hating all these major labels, label companies. It's like, well, are we sort of like being dominated by these companies? But somehow at this point, it's sort of like twisted. It's like, well, now those are the companies that's, having the legal team to protect our copyright. And for visual art community, if you look at that, it's like they don't have any, structure and they don't have, any legal companies to help them. But also think about film. It's like, Disney is known for, scrapping, not scrapping, like detecting super strict like copyright detector. And that's sort of like how people never gonna sort of like infringe their copyright. People wouldn't dare to do it. But in visual art, community is like people just do it and people just scrap it and people just trend something. And we are sort of at a weird time that 10 years ago people are like we don't want these big labels, but at this point it's like, well, seems like they are doing something, but there's also issue about are they actually also developing their AI tools to sort of like you know intentionally sort of like infringe some of their rights that don't have. But at least there are some discussion going on because of that legal team, the existence of those legal team. But also I think the positive side of that is that there are definitely tons of people that don't know how to sort of like create something to listen to or sort of and think about like playing an instrument. So there's also definitely a huge gap of that, is that can we sort of like engage more audience and engage more people into using these tools, but that sort of like stay at the beginning level. For professional usage, I would say we are still far away from anything like that. Yeah, I guess, and that also leads us to the last discussion question is that what is the goal of AI music? I guess I think I forgot where's the quote. That's what I didn't put in, but I think someone say something like, AI music is sophisticated enough when people stop talking about it like it's AI music. Think about it like computer music. Think about it like electronic music. When it started, like electronic music, when people are doing all the synthesizer, people are like, well, these are cool stuff. Come listen to our songs. And people are like, is that music? What are you doing? But at some point now, people getting used to that characteristic, that quality of sounds and that way of, creating music. And at some point, people stop like thinking about those music because of the tools that I use, but rather the music. And at the end of the day, we want good music. And how you create it as part of your creative process. It should be the integrated thing rather than, well, we just do AI music because we want to use AI tools. That's sort of like half of the music that we listen to today, which sort of like still themselves as AI music. It's like, what's the point? It's like, well, I want to do AI music because I want to use AI. But at some point we will be in that stage that it just become kind of obvious that there are certainly some part of it is being generated by AI, but people will stop sort of like talking about it's AI music, but rather it's just music. But somehow there are AI, there are electronic, there are computer music component of it. There could also be acoustic. No one will say, well, this is acoustically played music. That's sort of the point. People just call it music. But what is the goal of AI music? Are we, if you look at some of the AI researchers, you will be always questioning like, what the hell are people doing? It's like, why should we sort of like replace humans? But you know, if you think about in the AI way, it's like this is sort of like a grand challenge since you know day one of AI. We talk about the history, so people are like, you know, for AI research, some of the AI researchers, they are interested in seeing that whether we can just use computer to sort of like see if there are some spark of, you know, intelligence or spark of creativity. So that could be their goal. But you know, for musicians, it's like, what's the goal of AI music? It's more on music rather than AI. So does this tool actually augment ourselves? Does this tool bring us into, you know, new inspiration? So whenever you are thinking about some sort of like music and technology, the intersection, don't just think about, you know, you're using these tools, but think about what's the goal. Are you trying to explore these tools to sort of like get new inspiration, or, you know, you focus on the music and these tools are just getting you there? So that's something to think about. And this is a very interesting quote. Whatever you now find weird, ugly, uncomfortable, and nasty about a new medium will surely become its signature. So they're talking about sort of like, you know, think about tape or LP. It's like, it has its like own characteristic of sound, texture. So, you know, it just becomes its signature. People are like, well, this is the classic sounds that I like. Or, you know, think about early days, you know, guitars, electronic guitars, then you see that, you know, electrical guitars, they have their own characteristic that's just hard to, you know, get rid of. It's like, it's part of it. And, you know, at the time when it was invented, people are like, it doesn't sound natural enough, but at some point it becomes its signature. So, you know, I think AI music is also at that point. It's like, I actually like the music that's been generated like 2 years before that sort of have like interesting, sort of like the genre canon thing is like, it's not perfect, but there's something interesting going on. But when it just become, you know, it's too smooth, like think about the Suno generated music, it's like, well, it's smooth and it just sort of like cliche and sort of like just yet another boring song, then what's the point? But if you think about, you know, 2 years ago, some of the interesting songs, or, you know, if you intentionally break this AI models into somewhere that it just don't have any training data, that's when interesting start to happen, even though it sounds a little bit weird. But that's the point. It's like, what's the goal of AI music? And maybe it itself, the, you know, predictable behavior will become its signature. Any thoughts?
On the point of like thinking about like electric guitars as an example of like a technology that evolved to like imitate the past technology, and there's like been lots of like as recording technology has advanced and like all the above. I feel like what has come out of it and the value that it has brought is like when people find a way to utilize that sound and to like find what that sound is like bringing and like capitalize on that. And so I think that AI music is kind of like an anomaly in that way, because
Yeah.
it still needs to be treated as like a tool or like a collaborator, but like all of the like classmate comments said, like it doesn't have that innate like human emotional whatever. So like just straight up created AI music, I think that it will still be hard for people to like buy into that sound unless humans come in and like show you how meaning can be made out of that sound. Because otherwise I think that it's kind of like a moot point.
Yeah. But I guess, you know, think about like the thing like text to voice synthesis versus, you know, voice cloning is like sort of like interesting line. It's like voice cloning, you get more detail, you know, controls of it, and that's much harder than, you know, those like one-shot music generator. And this is one thing that I learned over the time is that, you know, generating something unconditional, it's just much simpler than, you know, you actually want more controls. But those kind of controls and interface and, you know, real-time feedback is the thing that we care about, so that it actually is have, you know, more, you know, detailed human intention inside it. And I think that's sort of sad that, you know, currently AI music just not operated in that way, most likely is, through some text prompt, and, it's human being creative and sort of like constrained into that, text prompt. And, if you know how people talk about music, it just doesn't make any sense. Like, how do we even sort of like think about like, I don't know, controlling the dough by talking about it on Reddit. That's it, without YouTube videos. It just doesn't seem possible to me. So I guess there's definitely a lot of like technical challenge in the way that I don't think AI music in the current shape is what musicians want. And we are so far away from anything that's actually preferable by actual users. But think about Suno as like, well, it's doing something, but if you look at their CEOs, the business model, then you will realize that it's actually targeting people who don't actually want to pay a lot of effort into learning learning an instrument, and learn about music. So there are people wanting that kind of tools, but doesn't mean that that's the only thing that we should focus on. There's something in chat. Innovate with AI music, like much of it seems very generic. How does creativity comes from AI without human intervention? I would say for now, again, I don't think the technology is mature enough. So for now is, mostly, we are limited into the control interface. Some of the interesting model you will see, sort of like 10% of the thing we talk about is having some interesting interface, but 90% of it is like mostly boring interface. And, things like generic is also something tricky. So in one of the, which one is that? I think the ambience one, right? They use their own, where is it? Yeah, but using their own composition as the primary training data, they ensure that the outputs stay true to their unique sound and artistic vision. So I guess this is one point of personalization. For now, I know a lot of teams are working on it, and it seems very challenging for now because think about machine learning and personalization. It's sort of like contradicting to one another. Like machine learning is sort of like learning from millions of songs and learn how to do it, and personalization is like, well, look at these 10 songs I've written in the past 3 years, and can you sort of mimic that and get something that's more of my style? But think about it, it's like two very extreme of the spectrum. But people are always looking into, either can we train a small enough model that just overfit on my own compositions, or the other way is like, well, I'm fine with these, these boring big models, but can we sort of like fine tune it at least as, through some control mechanism, make it my own. So think about, I think a easier analogy is like, think about Spotify. It's like when you start using Spotify, everybody get the same recommended, algorithm. But at some point, it becomes your Spotify, your, Apple Music. It's like at some point, it learns to adapt to your behavior. And is that something, AI music in the future will become? It's like, don't think about, just the creative part. If it's just something like in DAW, if you just like this preset, can the AI model just learn that? And, whenever you drag a new track, it's sort of like adapt to it and, adapt to your liking of sounds. And you start from that rather than start from plain, no presets. So that kind of like personalization, learning ability on the fly, that's something very challenging for now. And people are trying hard to do it. But for now, we haven't seen anything that's, super convincing yet. But, that's definitely something we will see some progress in the next few years. Cool. Any other thoughts? Otherwise, we would just keep.
I guess in the case of like what the ambient track did, with training on your own music, I guess would you almost prefer to overfit super heavily to the data set just so that you would really create a sound that was like true to you? Or because I honestly I think if you were gonna do music generation, that would probably be like the least ethically questionable like route. You know, just because it's like, okay, I mean, I'm just making music that, you know, sounds, it's basically just like giving myself an idea. So yeah, I just wonder that if you would almost prefer to overfit super, I mean, because again, nobody's, unless you're like already super deep into it, you probably don't have a ton of music, you know, to train on.
Yeah.
There's also the question of, because I'm all about, you know, more accessibility music for the average person. But I think, you know, I think if you want to create music, I think there should be like a base level of base passion for it. You know, like you said about just where it's, I think it should be more than just writing text into a, taking something and then getting something. I think it should be a little bit harder than that.
Yeah, I do hope like overfitting or your model could be a knob that's sort of like like distortion or overdrive that if that's something think about it, if that's your sounds and there's the one knob that's like making it me, but if you push it to the just maximum value, then you will get something that's just so you, but it doesn't have anything doesn't sounds nice. But is that sort of real-time control so that you can play with, that will be much more interesting rather than for now it's just that you can do this, you can overfit and you choose the best model. But I guess that's a lot of it is because of the interface, and currently these models are running on some GPU, so always you have to you likely know oh, the Jupyter Notebook or the Colab or the Great Lakes. That's just how it is for now. But if you work with Isotope, I think Isotope is one of the early DO plugin companies that use a lot of AI, but now Native Instrument also doing AI, and Cubase, I think they will also roll out some AI function. But over the time we will see much better AI interface than at that point. Then we can think about how we can potentially make it into more, okay, I don't know, like accessible way to actually do the thing that you want. I guess the point from moving from just thinking about does this AI music sounds good to the other level of I think that the community will soon realize the most important thing is like how many efforts do you need for these tools to actually fulfill your creative intentions. I think that's the point. And for now, at some point we will reach at that point is like think about ChatGPT and their friends, and then what is like Gemini and all different Gen AI tools. How do you even evaluate those? It's like, well, you can test them with the mathematical question, but is that the point? Is that what we want? I mean, most of the time, if you're using ChatGPT, maybe you are just gathering some information, or you don't want to do literature search. You just prompt it and get some, ideas. If that's the point, then, how do we evaluate this? And, I feel like the way how we should evaluate this is like, we have some intention. So think about AI music. It's like, we want to create this song. How many efforts do we need to get to there? And that could be the way, a better way to evaluate AI tools. But, we'll see. For now, I guess people are still stuck in the sense that can we just even generate something that, sound nice, good enough to our standard. But at some point, once that reach that kind of, ChatGPT level, then, things become weirder because, it's not just like generating pleasant sounds, but more, nuance on whether it follows your intention or does it capture your own characteristics. There are so many different dimensions that's just, for now, it's just hidden because of the pure quality just hasn't reached that yet. Yeah, but we'll see. I mean, I don't know. I mean, I don't know whether it will happen because, think about, I guess, the way how I think about music versus audio. And, it's sort of like novels versus text. So it's like ChatGPT can generate some text, but does it means that it can generate a novel? It's not like that. And, think about, generating some audio, generating these, random noise could be fine, but music is different. There are, story, there are structures. So at some point it will reach its, maximum capacity, and that maybe it's just impossible to generate something that's human-like. So I don't know. I mean, there's definitely some technical challenges, but on top of technical challenges, the way how we want AI music to go toward, I guess, and that's why there are always tons of debates and discussion in the field, and people don't agree with one another, and that's the interesting thing. Cool. Anyway, that's sort of a reflection looking at all these AI song contexts. And also if you look past look into the past AI song context, it's also interesting because in 2022 it's like few people are actively using those vocal models, but now vocal model is at the point that, well, it's sort of good, but it's not perfect, but it's somehow usable. But go to 2 years ago, if you look at 2022 AI song contest, is where the point whenever they use any vocal AI, you will definitely hear it sounds like robots. So it just evolves so fast. So you never know what AI song contest 2025 will be like, because now we even have more powerful model. And soul separation, 5 years ago, it's not like that at all. Now you can just go to GitHub and download a model that just sounds terrific. And there are Moses that's better, but 5 years ago it's not like that. Usually it's not production level. So we'll see. Cool. I guess for the rest of the minutes, I would just go ahead and keep talking about audio music generation. So that's was sort of like connect to the thing we are seeing in all these models, because some of these models are symbolic music generation. We talk about some of the symbolic music generation model in the past few class, but at the end of the day, you still want it to sound not like MIDI instrument, but more, the audio. So, from now on, we will be talking about audio domain music generation. So, we look into MIDI, we look into piano roll. These are the way how you generate those sheet music. But now more interestingly is how you can generate just raw waveform directly. That's possible, even though it's sort of like questionable approach, but there are also spectrogram generation. Then it's more like piano roll. If you look at this and this, you can sort of like guess what kind of model would be like, because they're basically similar in some sense. And finally, likely on Wednesday we will talk about latent space model. That's sort of like all the big Suno-ish model or Music Gen, Music LM, those are all based on latent space based model. Regardless of what their training data is, that's sort of the model that's based on. Cool. So just, I think we will just fast forward the recap up. We talk about discriminated model and generated model, but basically generated model is just, we want to generate something new. And we don't do it just like from nothing. We usually just learn this mapping from some noise to the data distribution. That's the mathematical way of thinking about it. And for most of the model, you don't realize there's some random distribution. But usually, if you look at the input, it's just some pure noise, and you sort of like want to morph it into, in diffusion model, morph it in 1,000 step into a nice looking, waveform or nice looking images. We talk about GM. That's if we can do this thing and go through a network, then we get this bean shape like stuff. Then how do we morph it into the actual distribution that we like. So, the idea of GN is just introduce yet another, neural network. And so this is the typical image, the figure you will see. You get some real examples, you get a generator that go from some random noise to some fake examples. And what you want to do is, train additional sort of like a police or, examinators things that just check whether it's real or fake. And so the goal of this discriminator is just to nail it on detecting whether it's real or fake. But at the same time, the generator will just look at that, the feedback from discriminator. If it's telling you all of these things are fake, then you should try to make it more real. So that's the point. You are playing this game between the generator and discriminator, where, discriminator wants to nail it on detecting which one are fake. But generator just try to improve their fake samples so that it feel real. And so this is basically what GN is doing. And if you train it this way, there are tons of like training challenges, but anyway, people figured out a way to somehow train it. Then, once you are done, you just drop that discriminator most of the time, then you can just grab something and then turn it into some waveform that you like. So we look into, how GN can be used to generate piano rolls. So, this is sort of the training progress. So over time, the generator just improves over time. And so does the discriminator. So that's a fun part of GN is like, well, there are some discriminator, but it will just co-evolves with that generator. So, that's the gaming behavior of it. And we also talk about diffusion model, which is a bit more complicated. But basically, you grab an image and you just add noise once for 1,000 steps. So at each step, you just add a little bit noise. And then at the end, you reach something that's just like pure noise. And so, diffusion model, this is the diffusion process. But the diffusion model, the interesting part is that we are learning how to reverse this process. So, we call this like diffusion, that adding noise. So, it's sort of like become more random. But what we want is this denoising. So we just train a neural network to do this denoising thing. So what you want to do is that you grab a more noisy, noisier input, and you want to sort of like predict how to get rid of it. So that's what you do. You learn to remove the noise, basically. So what's the point? So if you can do it 1,000 steps, think about it. If you get a white noise, and then you just do this removing noise for 1,000 steps. And somehow this model will just magically turn something back into the real images. So that's sort of the intuitive way to think about diffusion model. So, initially what you got is, just a bunch of random noise. This is RGB. So it's like not the white noise you see on, black and white TV, but, colored TV. This should be the white noise for them. But anyway, what you do is that at each single step for 1,000 steps, you just remove some of the noise. So at some point you will see there are like high level structure because you are removing those noise, and then you keep adding details to it. And at the end, you get something like that. So this is basically what the diffusion model is doing. So at first, you just get some low frequency component on the coarse shapes, and later you add more details to it. So people tried using this to generate music. We will also see later, in audio domain, but these for sheet music. So you first generate the structure, intro, two chorus, verse, bridge, chorus, verse, bridge again, verse, and X verse, I guess, and outro. And you can determine the, tonic center and scale. But anyway, this is sort of like a high level plan. And you go from this plan to something that's, easy Lee sheet. So you have a reduced melody and you have the just playing the chords without, playing any arpeggios. Anyway, and then you just keep going on, try to refine it. This is a better view. So you go from reduced melody to lead melody. So reduced melody is sort of like just getting the contour, like when you reach the highest note, or you reach the lowest note, rather than all the details. And looking at the chords, it's just like chords progression, holding the chords, And at some point it turned into accompaniment. So, you know, you actually play the chords, realize the chords. Cool. So that's what we've been talking about, mostly, you know, symbolic music generation. So today we were going to talk about, you know, how can we generate sounds, you know, actual waveform. So to start with, we will talk about this very crazy idea of, you know, just generating the waveform. So this happened sort of like in 2016. So if you look at waveform, this is like one of the figure that they have, seems to be one of the most cited figure in the field, is that, you know, if you look at these, you know, audio waveform, if you zoom it in, you see all these, you know, tiny points. So, you know, we have all these language models, we have these MIDI models that can just generate one, you know, notes after another, but we also have these, you know, ChatGPT model generate one word after another word. So, you know, this is language models, you know, predicting the next word given all the past sequence of words. So, you know, we talk about this, you know, a transformer is a blah, blah, blah. So these are more likely words. These are less likely words. And mathematically, you are just doing this, you know, conditional probability. You know, what's the probability of the next word? We want it to be higher than those other stuff. So, you know, that's the mathematical idea behind it. So, you know, people just being creative, you know, think about a waveform. It's still a sequence of numbers. Can we sort of like guess what the next number is given all the past numbers? And think about it in waveform. It sounds crazy. It's like 16 kHz. You have like 16,000. That's the starting point. Now people can do 48 kHz, 44.1. But anyway, that's when people start 16 thousands of numbers. You're thinking about generating those like ChatGPT. And, you know, the maximum span of ChatGPT is 1496-ish. And think about that, just like 40, I don't know, 0.4 second only. But anyway, that's the sort of the idea of these, the model that we're talking about now, WaveNet. So, you know, given all the previous numbers, like all the, you know, amplitude, like 0.9, 0.8, 0.7, what would be the next numbers? 0.5. But anyway, what's the next number? So, you know, I don't know what the actual, you know, probability is, but, you know, that's sort of the interesting part of it is like, think about the waveform, then you see how complicated it is. But anyway, the model, the goal is just doing this, you know, what are some more likely numbers than others? Anyway, tiny note, we don't need to care about it. But anyway, WaveNet is just basically doing that. So if you look at this, is that, you know, getting all the previous input, and you want to see what the next one is. So when it starts here, you get the next one and you put it here. And then when you get to the next one, you put it here, and then you do it again and again. So this is basically how WaveNet do it. And if you notice that, you know, this is basically just using a convolutional neural network for raw waveform generation. So how they go from this to this is basically, you know, using a convolutional layer, just slice through it to get it. So, you know, if you design your convolutional layer, smart enough, then you can do something like this. So just to recap on convolutional layers, what you want to do is to learn all these, you know, pattern predictors, detectors. So all these convolutional layer, you are learning these filters. So all these different filters will look into different stuff. So some of them will look at the edge, some of them will look at the beak, you know, and at the top level, they were just looking at the whole part, say, yeah, this is a penguin filter. But anyway, convolutional layer is that layer by layer, you learn these, you know, pattern detectors, and over, you know, the deeper into the layer, you get more complex pattern detectors. Cool. And, you know, what you want is to learn all these, you know, filters, but think about it like a pattern detectors that slice through the image to see whether you detect those things. And this is like convolutional layer. The neural network, you should be more familiar than other models because we've done this in one of the homework. But anyway, a bunch of, you know, convolution layer, pooling layer, convolutional layer, pooling layer, and flatten it, and then just go through some dense layer. So, you know, at the end of the day, it's just you know, a function mapping. That's the mathematical way to look at it. But you know, that's it. So the difference between, you know, WaveNet versus the, you know, standard convolution. If you do standard convolution, you get something like this. That's, you know, just go from 5 into 1. So you only get, you know, the previous 5 samples just to get the next output. So that doesn't work for audio because, you know, think about audio. If you want to sort of like understand what, I don't know, like 200 hertz sounds like, if you want to continue the wave, then you definitely a lot more samples to grab that frequency. So dilated convolution is what's being used in WaveNet, but basically think about it like a more efficient way that, you know, there's no overlap on this. So, you know, look at this, there are two, it's being fed to two things. But in this case, there is just no overlap. And for this, you know, even with 4 layers, you can sort of like have a much larger span on the past samples you look at. And so this is particularly used for waveform generation, because for waveform generation, you are always looking into, you know, you want sort of like more than 1,000 samples to see what the next sample is, rather than just the immediate previous 5 samples. So, you know, smaller receptive fields, that's the technical term, but, you know, what are the numbers of previous samples that's being used to predict the next output? And so in WaveNet, it's using dilated convolutional layers. So it has a much larger receptive field, which much better for waveform generation. So this is some of the generated music. That's coded music, I guess. So they are using the Maestro dataset. And so this is one of the very early model that just brutal force generating, you know, sounds. And these are waveform and just train on Maestro. And this is what they get. Where's my cursor? And there's no sound. Oops. Okay, let me try it again. This is just, you know, pure next value predictor for 16K hertz. So that's in 2016. That's what we have. So, you know, at that point, people are like, well, now deep learning is sort of like power enough that, you know, by just doing this, you know, boring GAN of, you know, 16K hertz and predict what the next sample is in, you know, -1 to 1. And think about it like, take a wave file and then predict what the next number, next byte it is, you know, 0, 1-ish thing. And you can do something like that. And what's more interesting is that even though it seems kind of boring, but people have found something interesting inside it, is that, you know, in this model, we are doing this convolutional neural network. And what they found is that, you know, some of these filters that being learned by the model look like this. So, you know, the black one at the back is the waveform, and these are some of the filters. So, you know, W1, W2, W3, W4, these are 4 different filter that being learned by the model. And if you look at it, you sort of realize that it's just the you know, the Fourier transform thing we talk about. You know, this is a specific you know, specific frequency. And if you slide through the audio that you have, you sort of do Fourier transform. And then you use this as a, you know, higher frequency thing. And this is, you know, lower frequency thing. And then you just slice through the waveform that you have. So you can sort of like detect things. So that's, you know, sort of like SDFD in some sense. So, you know, these 1D CNNs, even though we don't have any controls on what they learn, somehow they sort of learn to do the thing, and sort of suggest that, Fourier transform might be the way it should be. Why should we be doing waveform domain generation? And the other side here is like peak frequency detected by the learned kernels. So for each of these kernels, you can do Fourier transform to see what their frequency is, and these are the peak frequency. And you can see that, it's sort of like a very smooth frequency. So all these different kernels sort of like just detect different frequency, basically from 0 kHz until 7-ish. And you see a cut at 8 kHz and things here because, they are using 16 kHz in this particular example. This is not exactly wave that, but, this is doing classification, but this is something, likely being done within the model. So this sort of like bring us to the better way, or more straightforward way, is that why should we be generating waveform that just like one single number at a time? So this is more, natural way to do it, is that can we just generate this spectrogram and then later turn the spectrogram back to waveform? And, it's sort of like more like how we process music or audio. It's like, well, we listen to music and we hear different pitch, we hear different, ADSR, we hear different texture, rather than we hear the actual numbers of the waveform. But anyway, this is sort of like frequency domain audio synthesis is about. So what we want is to generate the spectrogram by the synthesis model. And the other part is inversion model, which sometimes called vocoder, which is kind of confusing. But anyway, that's how we generate the frequency domain audio synthesis. Actually, any question on these things? It's not actively used, to be honest. But this is cool because it's 2016. It's like sort of like almost 10 years ago. And that's the first time people realized that, well, we can actually generate waveform just by brute force. Yeah, just slightly different way. People just being creative, using same convolutional neural network, just that you tune with. So we talk about the stride thing, right? Like you can jump that filter. So instead of like just moving one at a time, this is basically you are striding at 2, and this one is striding at 4. So you have the size of your stride equal to the size of your filter. So you jump very rapidly, basically. So that's the dilated convolution. So basically you have the stride equal to the width of the filter, so that there's no overlap. You just jump, there's no overlap. That's basically the point. And most of the thing why it works is like how they train it, to be honest. But, it just showing that, it's possible to just train a boring convolutional neural network whose goal is just to predict what the next value is, and it can generate something like that we just heard. Tons of noise, but acceptable. There's something going on. Cool. We don't have much time, but we can just sort of see where we can go. So frequency domain audio synthesis, these are the thing that you should know. Usually is like 2-stage. So I think one thing we didn't talk about is phase information. So in all the homework, we are sort of like magnitude only spectrogram. So we can listen to it. So phase is important and not important at the same time. That's the main takeaway. So this is the real phase. So if you have this spectrogram, and if you reconstruct it using inverse STFD with the real phase, this is what it sounds like. And this is like with random phase. So phase, it's important, but somehow not that important as magnitude, as you can hear, that it's just, it just doesn't sound natural enough. So phase is, the way you think about phase is that, with this, you sort of get where you have that specific, frequency. So think about a sine wave. So we think about, SDFD as like decomposing the input signal into a bunch of sine wave. But not just about the sine wave, phase sort of like determine the locally variant of where that frequency that sine wave live in. So there are some tiny adjustment for each sine wave to move around. And so that's the phase information, and it's for each single sine wave that you have. So if you're doing random phase, it doesn't sound that good, but the pitch is still there, just that it doesn't sound good. But anyway, so if you do inverse SDFD without phase information, you can just do all these things, and assuming zero phase, it just doesn't work. This is what it sounds like. Oops, this is the original. So loud. And this is when you just do zero phase. So the thing why when you are assuming zero phase, a lot of things just cancel out, because that's sort of like the waveform thing. If you place two waveform, and then if you don't place them, wisely, there's a chance that they will, cancel out. So this is what happened here. When you're just using flat phase, then some of them might cancel out, unintentionally. So there's this famous algorithm called Griffin-Lim, but we won't go into details. But this is like pre-deep learning era, and this has been there since 1984. So this is one of the way people have been doing this, spectrogram back to waveform generation. So this is what Griffin-Lim can give you. And at the right, this is basically the algorithm. We can go over it, but it's very hard to see why it works. But I guess take it, and there's some theory behind it. But the idea is quite simple. It's like, well, we have a magnitude only SDFD. That's just this thing on top. We don't have the bottom one. So what it does is that, well, we just assume whatever random phase, and we just synthesize it. So what you will get is something like that initially. And then once you have that, then you do it the opposite way. You find the signal Y that minimize the loss between the input and SDFDY. So now you use this randomized phase, you get this, then you compute the SDFD, and then you try to minimize the spectrogram again. Anyway, I won't go into details, but the idea is that you keep optimizing the waveform and spectrogram one at a time. And the idea of the whole Griffin-Lim algorithm is that just doing this, I don't know, doesn't make any sense, boring game, for 30-ish iteration, then you will get something like this. So anyway, this is what people have been doing before deep learning, and somebody worked to some extent. But anyway, nowadays, we have much powerful model, and this is our models that's being used. That's why, some of the AI music generated, they sounds good in terms of the audio fidelity. At this, for 16K hertz, it sounds pretty good for 16K hertz. I mean, just the audio quality, not about the music itself. At this, it sounds like, a real audio recording of something. So these are some of the models. I won't go into detail, but you can use GN to do the thing. So go from spectrogram all the way down to this raw waveform. This is what people have been doing nowadays. So the idea of vocoder, what we just talked about, that inversion model, is that you will have some other model to generate this spectrogram. But anyway, you still want to turn this spectrogram back to waveform. And this is one of the model. So we talk about GN. These are, things that it can generate. So you get some, real samples. And at the generator, you just go from something that's, very small, and you do it the opposite way of how convolutional neural network do. So in homework 2, you are going from, a spectrogram and all the way reduce this, size until you reach, one single layer. But now for the generator, for these GM model is the opposite. You go from some noise and then you gradually increase the resolution until you generate something like this. And so you do this GM thing again and again, initially you just generate random, shady images, but over the time, discriminator improve, but also generator improve. And this is what you can generate in 2016, almost the same time as WaveNet. But these are the things that have been generated in 2016. But anyway, what they are doing is that, think about this is the sort of like opposite way of doing IS, Fourier, short-time Fourier transform. So what we want to do is that we take a slice on your male spectrogram. So this is like in homework 2 what you got. And you do this. You just increase one side of it until you flatten it into like one single horizontal line of numbers. And so this is the final audio that you have, and this is the initial thing. So initially it's like very small, like one slice of time beam, and then 2048 frequency beam. But at the end, what you want is large in temporal domain, but for frequency there's just one. Anyway, that's the thing, so you can think about, how you can do this with just a CNN. It's just playing with CNN configuration. But anyway, what you want to do is that you want to grow the resolution of the CNN, convolutional neural network. But at the same time, you think about these frequency as the channels. So you shrink the channels, but that's the idea. So you train some convolutional neural network that you can do this. So that's what Mailgun can do. Anyway, we will go into details, and this is sort of like no longer state of the art, but in 2020 is the state of the art. But it's basically doing the same thing. We can listen to some of the example to end today's thing. So what you can do is that, we have the, let's see if they have music. Nope. Just speech. Anyway, so this is like the input ground truths.
This commission can recommend no procedures for the future protection of our presidents, which will guarantee security.
And so basically they extract the spectrogram of just the magnitude, and they see how it reconstruct back. So if you use the WaveNet we talk about, like you can also train a WaveNet that condition on the spectrogram.
This commission can recommend no procedures for the future protection.
That's likely my laptop's noise. Let's do it.
This commission can recommend no procedures for the future protection of our presidents, which will guarantee security.
And this is their...
This commission can recommend no procedures for the future protection of our presidents, which will guarantee security.
Anyway, they all sound pretty good here, but if you have your headphone, you will see the difference. But anyway, this is what people want to do, go from spectrogram back to waveform. So that's the initial part. And, next week we will talk about differentiable DSP and how we actually get this so that we can generate something. Not next week, on Wednesday. Cool. See you on Wednesday then.